Railmagic have a tagline saying instant train automation. But this will mean that you can install our system in only an evening. In this video, I'm going to demonstrate the entire process of setting up the system. So when this countdown reaches 0, the first automated run will happen. The only thing I have done prior to starting this recording is to connect the co-commander to the command station and installing one code decoder in a locomotive and placed a magnet underneath the baseboard. Are you ready to learn about the 4 easy steps it takes? Here we go. We start the co-operator application on a tablet. In the main menu, we click on Co-operator Dispatching to open the control panel. Here we go into the menu and select a drawing mode. This allows us to draw a layout by choosing a track object in the upper menu bar and then clicking on a tile to place it. When a track object has been chosen, it is colored green, and 3 other track objects are colored gray. When clicking multiple times on the same tile, the system will cycle through the gray colored track objects to speed up the process. If we make an arrow, the object in the tile can be replaced simply by placing a new object on top of it. An object with a vertical bar terminates the track, whereas an object shaped like an arrow means that the track is continued somewhere else. Instead of drawing all the simple track objects ourselves, we can hit the Auto Connect button and the system will try to complete the design for us. We continue by placing signals. We have now completed the lower station and can draw the upper station in the same manner. The system allows the use of multiple panels, but we will draw the upper station on the same panel for simplicity. On this station, we use three-way and single-slip turnouts to show in a moment how they differ from simple turnouts. The sidings have not yet been installed on the layout, and therefore we draw them very short. There is a hidden third station which the trains will run straight through for this demonstration. We place 5 dot objects to tell the system about 5 unknown turnouts. The drawing process is now completed, and we can therefore store it and leave the drawing mode. This time, we enter the configuration mode in which the system wants us to enter information about each turnout. First, however, we will tell the system how the stations are interconnected. This is done by first clicking on one of the arrow objects and then clicking on the connected one. A turnout is configured by clicking on the tile. A dialog will be shown in which the DCC address must be entered. Click on one of the sit buttons to test that the turnout switches to the corresponding state. If not, use the invert button to invert the motor signal. For a double slip, there is an option to use only one motor, for example for Märkling. But in this demonstration, the turnout uses 2 motors. Check all the stages to make sure everything is correct. Then click Save. For this turnout, an address is already shown, but that is just a tiny bug. The configuration can go fast if you prepare and write the addresses down on a piece of paper before you begin. But for this single slip, I was not well prepared, so when I clicked the sit button, the state on the layout became wrong. I tried some of the other stages and could determine that the motors had to be inverted. Some 3-way turnouts have the blades to switch left and right at the same place, and therefore both the motors must be controlled to set a valid state. Other 3-way turnouts have the blades to one of the sides before the other, and therefore the state of the second motor is unimportant for some states. The 3-way turnouts on this layout switch to the left side before the right side. When we are done, we can go to the menu and click to store and leave the configuration mode. The control panel is currently not showing because the design is still only a draft. We can select to use the draft such that we can test it before replacing the final design. When the draft is selected, the turnouts can be switched simply by clicking on the tile. First, we go into the menu and select Measurement Mode. A new menu bar appears. We click on the button called Logo and select the locomotive we want to use for performing the measurements. The locomotive is currently standing here. We have to tell the system this by identifying the first turnout that it is going to run over. This is done by clicking on the Select Beginning button and then clicking on the tile associated with the first turnout. We then start the locomotive in the left direction. When it runs over the first turnout, the color is changed from green to gray. As it runs over succeeding turnouts, the gray color moves along. We continue to run until the arrow object has been passed. We click on the stop button as soon as the arrow object becomes gray colored. We click on some of the turnouts to prepare a new route. Because the locomotive has currently passed the arrow object and standing outside the drawing, we cancel the selection and run the locomotive to the right side of the arrow object. Here the locomotive is stopped and a new turnout is selected to be the first one. The locomotive is now ready to run through the station's first track. Again, we stop the train when it has passed the arrow object and prepare it to run through the station's second track. When the locomotive comes to a stop, the red distance markers on the control panel are removed from the tracks that the locomotive fully ran over. The red distance markers indicate which tracks that have not yet been measured. You can see that I click on both the slow and fast speed buttons to start the locomotive. This should be unnecessary after the next software upgrade. It is allowed to run over the same tracks multiple times as we do here. After setting a new route, we can start the locomotive from where it is without selecting a new first turnout. The system can automatically guess which one it will be. Here we run the locomotive to a new start location without measuring. As you can see, the locomotive got one set of wheels outside the track. Therefore, when it was started, the power supply went unstable and the system stopped the locomotive and displayed an error. We have to start the measurement of the siding again. You want to get as far into the track as possible to get the length correct. I'm unsure why the locomotive suddenly stopped here. Now, most of the station has been measured. That is enough for the system. As long as we keep out of the unmeasured tracks, the system will work and be able to keep track of the position of the locomotive. I won't waste your time by showing the measurements on the upper station as they are carried out in the same manner. We go into the co-operator driving mode and run the locomotive over a piece of measured track. The locomotive is controlled by scrolling upward on the green bar. The light and dark colors show the speed. We see that the signal bar increases the number of gray bars as the locomotive runs over magnets. When the position becomes known, it changes color to green and shows 5 bars. We stop the locomotive where we want to place the first signal and hit back into the dispatching mode. In the menu, we select Implementation Mode. Make sure the locomotive is selected. Then click on the signal you want to implement. The cool thing is that if you have stopped the locomotive in the position where the signal is wanted, you can now click on the Load Position button and the system will automatically calculate the input values. All you have to do is enter the DCC address of the signal. Let us make a few more signals. I'm switching between the co-operator dispatching and co-operator driving modes. It will be better to have simultaneously access to both by using a smartphone together with either a tablet or a computer. Note how the distance to the next signal at danger is shown here. However, the train will not stop this time because the virtual engine driver is not enabled. We are, in other words, controlling the locomotive in a manual mode. The virtual engine driver is enabled by clicking on the VED button. Are you ready? We now stop the locomotive, change the direction, and enable the virtual engine driver. The speed bar becomes gray to indicate that you cannot control the locomotive manually any longer. The speed bar decreases and the locomotive slows down. When it comes to a complete stop, the number of the signal is shown. We can now run from this signal to this signal by clicking on the first one to turn it green. But we forgot to leave the implementation mode, and therefore the settings dialog for the signal is shown. Now the control panel is operational. We click on the signal and it becomes green. It automatically turns red after the locomotive have passed it. To continue, we can set up a route and turn the second signal green. The distance to the next signal at danger is shown to be greater than 10 meters. We stop the locomotive manually. When we change direction, we see that it has found the first signal we placed. We let the virtual engine driver take over again. The signal bar shows that the tracking briefly had a lower precision, but it is shortly after restored. We try to run to the same signal, this time partly through the first track. There are three ways to start a locomotive standing at a signal, either here or in the list of locomotives, and of course from the dispatching panel. From the list of locomotives, it is also possible to easily stop the locomotive in case of an emergency. Jumping fast forward, I have placed a few more signals. I want to demonstrate two things. We start the locomotive. Now, when it gets to the next signal, we are going to turn the signal green before the locomotive has reached a complete stop. You will see that the engine driver therefore cancels the braking and starts to accelerate instead. Also, I want to show that the signals can be located very closely. In fact, there is no limitation. If you liked what you saw, you should check out Railmagic.com for more information.